A quick example on shadepointers as formal parameters. I have this entity class again for this example, and then I have this display function, which has a formal parameter, a shadepointer parameter, which is of this type, shadepointer, and I pass an entity. Okay, just some display or print function, and within that, in the body of that, we do a check to check if that is null pointer. If so, we print out null pointer. Otherwise, we invoke the toString function on that. So shadepointer parameter, we do toString. Then I print out the shadepointer parameter useCount, and then I print out the useCount for that. Okay, in the main function, I go and construct the shadepointer1, and I use the makeShade and pass an entity for that, and I construct that using 55 as an argument. In the next statement, I do console output shadepointer1 useCount, and I print out the useCount. Then I invoke that display function and I pass in shadepointer1, and then I print out the shadepointer1 useCount again. So as an exercise, maybe pause the video for a second and think about what the output is going to be. Alright, build around that, and we see we get shadepointer1 useCount is 1. Then we invoke that function, so we get the toString function printout, which will print out 55. Then within the display function invocation, we get shadepointer parameter useCount is now 2. Two shadepointers now manage that heap object. Of course, we pass by a value, not by reference. Following the display function invocation, program execution returns to the main function, and we get shadepointer1 useCount is 1 again. Only one smart pointer, in this case a shadepointer, will reference that heap object. And then program execution reaches the closing brace of the main function, and we get entity destruct invoked because again that shadepointer now goes out of scope. The reference count for that entity heap object will be 0. No object will be referencing that, so it gets the allocated entity destruct invoked. The member was 55. Again, remember in main we have the shadepointer1. We do the printout shadepointer1 useCount before we do display. Within display, we are going to print out null pointer if the shadepointer parameter is null pointer. Otherwise, we are going to do toString, and then we do this printout as well, shadepointer parameter useCount. I can do something like this, so we can see that this printout happens within the display function. Okay, so we've seen pass by value. I pass in that shadepointer here, and that it gets passed by value right now. So let's do pass by reference. Okay, so this formal parameter, the shadepointer parameter, is now a reference to a shadepointer entity. Back in main, I'll do the same stuff. I'll do this printout shadepointer1 useCount, then I'll invoke the display function, and then I'll do shadepointer1 useCount again. As an exercise, pause the video for a second and think about what this will display if you build around this now. Okay, I'll build around that, and you see we get shadepointer1 useCount is 1. Then we get 55 printed out in the toString in the display function, and we get displayed shadepointer1 useCount is 1 now. Remember that we are passing by reference, so the shadepointer parameter is basically an alias for the shadepointer1. Essentially, that entity heap object now only has one shadepointer that owns that. So we return back to the main function, and then the reference goes out of scope. We can see that does not clean up or deallocate the heap object. Again, that was just a reference, so shadepointer1 useCount in main is going to be 1. Then we get end of program and entity destruct invoked again. Now for an exercise and for fun, you can play around with passing by R-value reference, but to wrap up this video, I want to show you one final thing, so I'll change this back to a pass by value. So make sure the formal parameter is no longer a reference. And then in the display function here, I can do move. Again, as an exercise, you can pause the video and think about what we will get when we build around this program now. Alright, I'll just build around this. In the main function, we'll get shadepointer1 useCount is 1. Then program execution moves to that display function, so it will not be null pointer, so we get 55 printed out. Then we get this useCount printout within the display function. Shadepointer parameter useCount is 1. But remember here we use the move function, so when program execution reaches the closing brace of the display function, we will get entity destruct invoked. Because that shadepointer parameter object is now gonna go out of scope. In other words, the useCount will get decremented to 0 and it will invoke the destructor, so entity destruct invoked. Member was 55, that is correct. And program execution will return to main, so we get shadepointer1 useCount is 0. Again, remember we use the move function to move ownership of that entity heap object from the shadepointer1 to the shadepointer parameter. And then we get the end of the program. Back in main, the display function is gonna move ownership from shadepointer1 to the shadepointer parameter. When program execution reaches the closing brace of the display function, again shadepointer parameter is gonna go out of scope, right? The useCount is decremented and that entity heap object gets deallocated. And that is why in this statement, the useCount for shadepointer1 will be 0. Now we'd like to note that for the most part, you will not do this move here with shadepointers. There is a slight optimization with that in that we do not have to go and increment the useCount for the heap object, but then you have the problem where in this example, the shadepointer1 is no longer managing a heap object, so when you try and dereference it later on or try and invoke a function on it, again it is no longer managing a heap object. That can cause you some headaches. Now for slight optimization, you can do the move here in the case where you know that you will not be using that shadepointer again. later on in the function, for example, but for the most part this is not necessary, and it is not always worth doing because it's only a small optimization that you get from that. So it's best to just pass in your shared pointer like that. Alright, that is going to wrap up this lecture. I'll see you next time.